and welcome to TecQuipment's Wednesday live Q&A session on the of Chinese deals. And I'm joined today by Dave Giddings. Are you there, Dave?
Hi there. Good afternoon, Dion, and the world.
Good. Let me just mute that extra thing in the background. There we go. Right, so first of all, I'd like to start out to say a shout out to Jeff Hull, who's in New Jersey in the United States. Great to see Jeff with us once more.
Hi, Jeff.
We do have a guest. Our guest today is Isaac Whitehouse, but Isaac is a very busy coastal engineer at the moment, and Isaac is going to be joining us in a few more minutes as he gets back to his desk. I think he's had a meeting that overran, but that doesn't matter because, Dave, we've got time to chat. We've got things we want to be talking about, including vacuums, not the Hoover
Okay.
type or the dice, but vacuums in a room.
Right.
So what snacks, first of all, Dave, what snacks have you got on hand today?
So you broke up a little bit there, Dion.
Did I?
Yeah.
Any pickled eggs or crisps or biscuits on hand?
No. In fact, all I've had today is a piece of toast. Very, very poor show, to be honest.
Oh my goodness!
Nothing.
You know what? Look what
Nothing.
I've got. It's not going to show very well. These are amazing. It's green and black.
The background's interfering with it.
Hopefully you can see that now. If I hold it a certain way.
Yeah, quality. That is.
Quality.
Yeah.
Green and black, dark chocolate with orange fruity middles. That's my snack of choice. It's like
is that
a little.
Part of your 5 a day?
Yeah, definitely. It's like a little. It's almost like a Jaffa cake in a chocolate, but better actually.
No, it's not better though, is it? Jaffa cakes don't even go there.
Well, if you go to France as well, you can get multiple flavors. Anyway, today I'm going to kick off by bringing my son online, actually.
Oh, okay then.
He asked me a question at the weekend about putting air in a room, taking air out, and the creation of vacuums, and I couldn't explain science, frankly. So I said, why don't you come on the Q&A live and ask the question? So this is the point where hopefully he doesn't get blotted out by the landscape. He can sit on my knee. There you go. Right, Alex, you look at that camera right there.
Hello, Alex.
Hello.
So you ask your question now about the air in a room.
So what if there was a room that you could control the air, and each half a millisecond it switched to no air in the room and loads of air in the room.
Oh wow. Well, I'll tell you what, before we even go down there, let me just help you along a little bit and just talk about what a vacuum is. Okay. Well, a vacuum is an area or a space that is devoid of any matter, of matter. Okay. The word vacuum comes from a Latin word vacuus, which means void. Okay. So vacuum is a region where the pressure, or the gaseous pressure, is less than atmospheric pressure. So everything on Earth, okay, everything on this planet has a mass and therefore takes up space, therefore is matter. And even a gas is a matter, okay? Now scientists and engineers are able to create a vacuum using a vacuum pump. So it could be a room that you're talking about, it could be a bedroom, it could be a sealed container, and it could be a vessel. So when this happens, there is little or no pressure left in the sealed container. Okay, so that's a little bit of a description of a vacuum. So going back to your question then, for your room to be suddenly turned into a vacuum, in the time that you've mentioned, so in milliseconds, it would take a considerable, powerful vacuum pump to do that. Now, on our equipment at work, Alex, we have a supersonic wind tunnel that uses a very powerful vacuum pump. Now, Dion will be able to show you afterwards this AF302 wind tunnel, which featured on our YouTube Aero Live show. So we are aware of massive vacuum pumps, and they are big and they are powerful. I wouldn't recommend you are in this room when this vacuum pump switches on, because of the fact that it would take out all the air and you won't be able to breathe. So we wouldn't want that, Alex. But it's an interesting experiment that you're considering. I don't think your mum will appreciate you doing this experiment in your house, though.
Right, good, brilliant. Thank you, Dave. You can send him on his way.
I'm gonna now go off on one now. You know, I like to do this once a week, but I like to sort of go off on a bit of a tangent now. You know, whenever you see these science fiction films, and you see the Death Star exploding on Star Wars, you see on Star Trek the Enterprise blowing up enemy ships, the Borg cube or whatever, or indeed on more serious science fiction films like Alien, where you see the Nostromo self-destructing. The fact that you can hear this is actually false. This is not true. It cannot happen, because the problem is sound does not carry in space. Okay, it simply doesn't. But Hollywood hasn't always got it wrong. For example, on 2001 Space Odyssey, the famous Stanley Kubrick classic film, we see shots inside the spacecraft where you can hear machinery, engines, and talk and spoken language. But the moment the camera pans to outside the spacecraft, there is a deathly silence. There is no sound at all. Okay, and so, you know, Hollywood gets it right sometimes, but in the most part on science fiction films, it simply gets it wrong. And the last mistake they make is when you see a star exploding on a science fiction film, you see the explosion and you hear it at the same time. Well, this cannot happen, because as we know, light travels at a much different speed to sound. So you'd see the flash first of all, then you'd hear the explosion. So strange things happen out there in space, Dion, I'm telling you.
Right, okay. So Space Odyssey watching it is tonight then?
Yes, it's a classic. It's an absolute classic film, yeah.
I just want to do a few shout outs to a few people. We've got Hendrayanto who's joined us. Thank you for being with us. Andy Ratcliffe is there as well.
Hi, Andy.
So do feel free to chime in with your additional suggestions on content, Andy, as well, while you're sat in the background. Don't forget, you're watching live. You can ask questions. You can contribute to the discussion in the live chat box. If you're watching on demand, you can also put your questions in the comment box below after this webinar has streamed. Okay, so Dave, going back to the whole talk about vacuum, have we got any apparatus at TecQuipment that would help illustrate the change of air temperature or anything like that?
Well, we do an emissivity experiment. I think that's the TD 1011V with built-in VDAS. That's a natural and convection experiment, and that looks at how different types of heat conduct in a vacuum and in a positive pressure environment. So yeah, it's not really completely relevant to what you said, but it like I said, it just looks at how heat can transfer, you know, and it helps understand the Stefan Boltzmann constant law. Okay.
Right. Okay. And when would you see a real life? I know I probably shouldn't ask you this today because we're going to be talking about physics tomorrow. But for those that aren't able to make it tomorrow, when would you see a real life application? When would you really need to know about the Stefan Boltzmann law, for example?
Oh, I'm not going to attempt to make myself look stupid and talk about the Stefan Boltzmann law. But this morning you were talking about gas as well. Yeah. And I mentioned that the TecQuipment cover a lot of the gas laws experiments. So that I think there's 5 different gas laws. We have Boyle's law, which of course we cover. We have Charles's law, Gay-Lussac's law, and then it gets a bit more complicated because there's combined gas laws. So you're doing a search there, and that'll pull up 2 or 3 different experiments there.
Okay, great. So you've got this expansion.
There we go.
Perfect.
We've got the ideal gas law, Gay-Lussac's law, yeah. Because one of these experiments, we actually discover that when you pressurize a gas, or oxygen in this case, we can actually observe the temperature rise. And equally, when we subject it to a vacuum, using a vacuum pump on the panel, we can see the temperature drop as well.
So if, for example, we go back to the room scenario, I did get a massive pump and connect it to the child's room, the temperature plummet.
Yeah.
But
And remove the child in the pump.
maybe
So a giant vacuum cleaner.
Right, okay. This is not recommended to home, children, girls and boys.
No, do not try this at home. I am not liable.
Okay, well, joining us very soon, we've got Isaac Whitehouse, who's on the way now. He's just making his way into the room, walking the stairs to our digital meeting room. There he is, look, all in his high vis and everything. You look like a proper engineer. Hello, Isaac, can you hear us? Now we can see you, but we can't quite hear you yet. So I'm hoping that your audio is now connecting. Brilliant.
I think it's connecting now.
Yeah.
Yep.
Can you hear us, Isaac? Let me ask to unmute. I'm going to unmute you, Isaac, or ask you to unmute yourself.
Hello.
Hello.
Hi, Isaac.
Being late.
It's brilliant to see you, Isaac, and to hear from you again. So let me introduce you. We've just been talking to Digital Dave now. We're talking about vacuums and expansions of perfect gases, etc. Our guest today is Isaac Whitehouse. Isaac is a graduate coastal engineer, and there he is in his home. Have you been out on site, Isaac?
Yeah, I have been. Basically, we were digging for a pipe and it wasn't in the right location. So then I called the camera crew to find the right location, and it was a meter to the right.
Oh dear. Well, it's quite admirable. Well, we were doing a live Q&A with Isaac at 1 o'clock, and we were done about by 1:30. Isaac then had to go out and do work, have a meeting, and then you're back online here with us now. The power of the modern world. So thank you for making it back. Isaac, we want to talk about, yes, you are a coastal engineer. What made you want to be a coastal engineer in the first place, and how did you get into it?
Well, what made me want to be a coastal engineer is I got fascinated with the coast when I went on a trip to Ireland and saw the big waves crashing off the cliffs there. So then I went to do a degree in coastal geography, which then basically worked into, there's 2 options out of there. You go and be go to coastal management, or go and become an oceanographic scientist. And I was more interested in being on the coast, so went with the coastal management, and a degree in coastal engineering helps that along.
Very good, excellent. How was your experience did you spend lots of time doing practical during your coastal engineering course, or was it all
It was about 50-50 with modules that were just purely informational, and then the other 50% and my dissertation was practical, where we did experiments and then worked out results from them.
All right, great. How would it, I guess practical was pretty essential. What if you were, like many students are at the moment, they're not allowed in the labs? How would you deal with that?
I'd insist on being granted the time in the labs afterwards then. You know, when everything's back to normal, I'd like extra lab time.
Yeah, okay. So potentially what we're looking at is when people go back in September, if they're like you and thinking that, then they may be going back and saying, well, actually, I've missed out on all my labs now. I want to go back and I want the labs for this year, but I also want the labs for last year as well. Yeah, okay. Well, that's going to be pretty tricky with all the social distancing. It remains to be seen how, I mean, different people are coping with it different ways. We had Oliver Shaw from Trafford College. He joined us a couple of weeks ago, and he was talking about how they're practically handling the social distancing in the lab, and they invited students back, and they've been doing lab sessions with them in small groups. They really utilising the VDAS that TecQuipment offers, so that you can have a couple of people on an experiment, and then more students watching remotely or even in another room.
Yeah.
So I think that will be very, very powerful and useful for many. They've proven it's working well for them. Okay, so now, Isaac, we want to talk a bit about, yes, you mentioned you'd want more lab time if you're a student. Earlier, you were talking about some friends you had and how they've had problems achieving their learning outcomes during this year. Perhaps you could explain that and how you think they might be dealing with that. I think you've got PhD student friends.
Yeah. PhD, my friend is doing a PhD, can't go out and collect data because it would mean he'd need to meet up with people from various different places to get access to where he's taking his measurements. So what he's got at the moment is he's got the historical data that he's using, but he can't get fresh perspective, so he can't check that what he's got is correct.
Right. Okay. That is a difficult situation. Okay. Well, hopefully, as measures relax, he might be able to get out there and start gathering more of his data. Fantastic. Now I'm going to give you a bit of a break, Isaac. I appreciate you probably just run straight into your home office. And you might need just a cup of tea to settle your nerves. I'm going to hop back over to Dave now. Dave, I want to go back and talk about gases again now.
Yeah.
In what part of a mechanical engineering course would you be teaching students about gases, and how does that, can you reflect on that, or am I moving beyond your comfort zone here?
Well, I can only go on what I see in the labs, in my role, Dion, and there's no real pattern. I see different equipments in different labs. There's a crossover between so many different product ranges anyway. We know there's a link between aero and fluids, between thermo and just basic mechanical. So I can't really say the sort of courses that these are key to, and again, every country is different as well. What I see in Ethiopia will be different to what I saw in Papua New Guinea. So there's no real hard relationship. And I don't really come into contact or see the syllabus, for example. I just react to their calls for help, or please come and install this equipment,
Now, if I say, for example, you've got these in your labs, you coming up to summer, lots of people are shutting down, okay, except for Australia, that has got the other end of the academic spectrum. Many people around the world might be shutting down for the summer, though, unless they're, of course, running summer schools. Is there any prep you need to do on these particular types of apparatus to put them into a state of,
Well, yeah, I mean, the worry is for us that a lot of this equipment has already been in lockdown. Not only the people in lockdown, but the equipment's been locked down, and it may have been left rather quickly. So people would have, like we got locked down on the 23rd, and it was literally, that was it. It wasn't quite like Chernobyl. We didn't quite just leave as quickly as that, but a lot of this equipment will still have water in it. A lot of the load cells might still be in an energized state. So if the technicians can get into the labs and check on the state of the equipment, that would be really useful to us. And we can give advice. We can tell you how to clean your reservoir tanks, how to empty the water out of your flumes, out of your tanks, out of your pump machines, your Reynolds numbers, all sorts of equipment. We can give advice for sure. But it's not just fluid mechanics. Like I mentioned, it could be mechanical engineering where you've got load cells that have been left in their energized state. So we want to make sure they're backed off. So yeah, it's important to get this message out, and maybe we need to put a message on our website. You know, if people need some help or guidance on how to decommission, but ideally recommission in the coming weeks, or hopefully not months.
Now, if you've got, say, watertight marks on some of your apparatus because you've had to leave it and there's water still in there, and perhaps the water's not, it's been sat still for some while. How would you go about cleaning that off?
Well, I mean, to get the water tides off, you need to empty the tanks of water. So on our pump rigs, for example, or cavitation, any equipment that has a reservoir, empty the water safely, and then just get some cleaning material. Nothing too harsh that will take off the skin or the shine off the equipment, but yeah, just elbow grease really. Okay,
good, brilliant. So top tips, I suppose, for decommissioning over the summer period is
getting water out of the equipment, and flushing it through with clean water before they disappear.
I'm not going to put any cleaning fluid in that water, just clean.
No, I'd rather not. I mean, I know on our hydraulic benches we encourage some extract of barley to be introduced, if you like, periodically to avoid any build-up. But no, I wouldn't use any detergent.
Okay. No. And those load cells, that's a really important point.
Very important. It could be a pin jointed frameworks. It might be a torsion specimen on the SM1001. Just make sure those load cells are backed off for sure.
Right. Okay.
And disconnected electrically as well.
Right. Good. And do you want to take all the batteries out of things, or?
I would on the digital dial gauges, the Mitutoyo gauges, for example, that if they're not switched off, then they don't power down automatically, and they can wear down. They do wear down over time. We have seen that ourselves. Yeah.
Okay. Bruno's made a really good point that the manuals do have lots of tips, good advice on maintenance. So it might be a time for the lab technicians to just pull those out, check them through for any specific product tips on there.
Yeah, but equally, don't be afraid to contact customer care at. We can always offer advice personally. Yeah.
Fantastic. Okay, Dave, thank you very much for that. Isaac, I'm going to come back to you with a different question now. I want to talk about inspiration to be an engineer. Did you have any particular role models, maybe famous people or people in your own life, that inspired you to pursue your engineering beyond the wonders of the sea?
Definitely my grandfather, and I liked hearing some of the stories of what he got up to, and also probably Brunel. I like Brunel.
So what did your grandfather do?
He was an engineer on various different projects, from laying pipes to constructing pavilions on the seafront.
Okay, fantastic. You've got a real engineering family, haven't you? Your dad and your mum, and awesome, brilliant. Well, you are very lucky to have a personal role model in your life. I know some people struggle to pursue it, really grasp engineering without a real life role model there. Good. And if you were to kind of tell the young people of today, maybe those who are considering their career choices, maybe they're applying for universities or colleges for next year, what would your message be in terms of why you should consider pursuing a career in engineering?
Lots of fun, different challenges all the time, and then 100 different solutions to each problem. And it's just, half the time I find my job very, very entertaining, and the half the time I'm walking on a beach.
Brilliant, lots of fun and lots of solutions. I like that, fantastic. All right, Dave, I'd like to hop back over to you now, because Dave, we're going to be quickly talking about what we've got coming up for this month. Yesterday we had a meeting about the webinars that we're planning for this month. Because we are only doing Q&As and webinars throughout July, we are having a break in August.
Yep.
A much needed break, because it's been pretty full on, hasn't it, Dave?
It has, yeah. Not sure how many we've done now. It must be about maybe 12 or 15, possibly more.
Something like that. We've been going since end of March, weekly, on both Q&As and webinars. The last webinar that we're going to do in July, on the 30th of July, is going to be a bit of an outtakes webinar. We're going to reflect on all of these wonderful sessions, pull out some funny outtakes, and we encourage everybody who's watching to give us, perhaps highlight their favourite moments and their funniest outtakes there as well. So, you know, feel free to start putting your comments in the chat box or the comment box on YouTube, so that we can dig those moments out and share them with other people.
Well, you know what, Din, I've just had one. The cat has just attacked the dog. It's really kicking off here now.
Oh, no.
Look, Lorraine's left home. Right? She left.
Oh dear.
Yeah, it's all going off now.
Oh no, I know. This is where the cat comes flying across the screen, and the dog.
It's all about food. It's all about their food bowls, and it's just conflict. It's conflict now.
Oh dear.
Yeah.
Well, I'm not sure what to suggest.
But I'll just shut the door.
Yes.
Let nature take its toll.
Okay. Put them in the garden. I try that with the children sometimes.
Yeah.
Right. So, Dave, what other questions now? Well, no, actually, what I was losing train of thought, and sometimes that does happen. What else have we got coming up in July?
Oh yeah.
We've got Roger Penlington joining us in a couple of weeks' time. Roger is going to be talking about blended learning. He's from Northumbria University. That will be a very interesting session from him. He's also involved heavily in the UK Engineering Education Research Network. So we'll be joining us then. We also have some people from Nottingham Trent University hopefully joining us to talk about autism and ADHD and working with students who have who struggle there. So that academics can understand them and fellow students can understand them, so that we can all help work together in a more harmonious, effective way. So those are some of the things we can look forward to in July. If you have any specific requests of content or things you want us to cover throughout the rest of July while we wrap up this season of webinars and live Q&As, then please do put them in either the live chat box or the comment box. Okay, so Dave, I'm going to flip back to Isaac now, and I want to say a big thank you, Isaac, for joining us today.
It's all right.
I know you've had it full on going out in the field, etc. Before we leave, I wondered if you could tell us what your typical day is like, just for those who may be considering a career in coastal engineering, or everybody else who just wants to have an appreciation for what you do.
Well, the day is basically two different types. You've got the inspecting assets that need regular inspections, such as sea defences, deflection screens and stuff like that, that needs to be checked. That's all right. and then the rest of it is responding to residents. So that takes basically a day to do that, and then another day would be respond to either a complaint that a resident or a member of the general public or another member of the council has raised, such as a leaking ditch. Haven't had any of them recently. And then basically fixing the problem, and in various different ways, such as it could be as small as sending in a contractor to relay a couple of curbs to a small scheme up to £20,000 worth of work.
Okay, and now, so one thing that we haven't spoken about during the YouTube live, you explained who inspired you, and I'm not sure whether you mentioned you did your geography degree and then went and did your master's in coastal engineering. What's the plan for the next 5-10 years? So you're out there doing inspections at the moment. Where do you see yourself going to once you've gained all that level of experience onto now?
I hope to get more design works on larger projects, such as possibly a tidal lagoon, or making a new harbour, something like that.
Oh wow, that'd be cool.
Yeah.
Okay, fantastic. Well, I wish you the best of luck with your future harbour project. Let's be aspirational here. And thank you so much for joining us today. I want to remind anybody, if you've got any more questions, then please do put them in the chat box, because we are going to be wrapping up in just a few minutes. We've just had a question, Isaac, and the question is, where are you based?
Northeast Lincolnshire, just south of the Humber River.
Okay, so where is your nearest seaside town?
Cleethorpes.
Cleethorpes, okay. Very, very nice. All right, fantastic. That's it from us today. Thank you, Isaac. Thank you very much, Dave, for being with us. We will be back again on YouTube tomorrow, 1 o'clock British Standard Time, on Thursday, the 2nd of July, and we will be talking about physics. Here we are talking about physics in terms of physics A-level. So if you want to learn about how to teach the mechanical side of physics, but also the electronic side, because we are joined by Liam Walton from Matrix Technology Solutions. So we'll be covering the whole of the physics A-level syllabus and looking at how you can take the theory into practical applications to really help the students emphasize, embrace those concepts. So do join us then for that, and look forward to more webinars and the rest of the Q&As coming up throughout July. Thank you very much for joining us today, and see you again soon. Goodbye.
Bye now.